Hi class, let's take a look at problem 4. Now problem 4 we have to be a little bit careful. We're given a graph of a function and notice that, well, some of the points are overemphasized and also it has removable discontinuities, meaning it's not defined at 2. On the actual graph it's defined somewhere else, and then also the function is not continuous. It has a break in the graph along with a couple holes. So let's actually take a look at which some of these limits, especially on A, they're asking at 2, but coming from the positives. Now, just as a reference, this is 2. Coming from the positives is on this side. So the limit as x approaches 2, your y values are going to get infinitely close to 2. So in this case, this is 2. The next one is the limit as x approaches 2, but from the negatives. Once again, this is 2 from the negatives. You're also going to get the values of 2. Okay, now next one is the limit as x approaches 2. And notice that coming from the actual, coming from the positives and the negatives, as it approaches 2, your function gets extremely close on both directions to 2. So in this case, we would say that the limit is defined at 2. And that is because on both ends, the actual function approaches the values of 2. That's it for this one. If you had basically not an agreement on coming from the positives or the negatives, then the function is not defined at 2. Now, part D is asking for f of 2. F of 2 is this dot, not on the function since it has an open graph or an open hole. And in this case, this is equal to the values of 1. That's actually it for D. So careful, it's not 2. The function is not defined at 2. It's actually not continuous at 2. And your function value at 2, it happens to be 1. We're looking at this dot here. Next question is the above function continuous at 2. In this case, I actually already said it, but let me write it up. We would say something along the lines of no. F of x is not continuous at 2 since the limit, as x approaches 2 of f of x, this is supposed to say limit, let me fix it, is equal to 2, and f of 2 is equal to 1. The proper definition is going to come up in the next section on how do we define a function that is continuous. And for functions that are continuous, you have to have that, well, the limit on the right and on the left approaches the same y value, and also it's defined at that y value. So for example, at 1, you could see that the function coming from the positives and the negative, the limit is equal to 2. F of 1 is equal to 2. So therefore, it would be continuous at 2. This one, it has a hole in the graph. Because of the hole in the graph, it happens to not be continuous. The limit does exist, but not a continuous function at 2. That's actually it for this problem.